Today we're going to be talking about investigating polynomials. So first let's define a polynomial. A polynomial is a monomial or the sum of monomials. It says a polynomial can be classified according to how many terms it has. So you have a few definitions to copy down here. So my first one is a monomial. It's what we talked about yesterday. An example is going to be 5/2 x squared y to the third. It's one term. Okay, so a binomial, so bi meaning two terms. An example, 4x squared minus 9x. I've got a trinomial, which means I have three terms. So 2x squared plus 3x plus 1. And then I have a polynomial, 3a to the fourth b plus 7b c squared plus 6cd minus 8. It's four or more terms. So if I have more than four terms, it's still a polynomial. So next definition let's look at is the degree of a polynomial. The degree is equal to the highest degree of the monomial term. So we're going to work a few examples. So let's look at some of the sample problems. My first example is 5/2 x squared y to the third. So since this is a monomial, it says I want the highest degree. My degree is the number of exponents I have. So if I look, I have a 2 and I have a 3. So my degree in each term is 5. That's also the degree of my polynomial because I have a squared and I have a cubed. If I add those together, I get 5. So let's look at an example of a polynomial, or excuse me, of a binomial. So my 4x squared minus 9x, if you look the degree of each term, the first one is squared, and the second one is going to be to the first power, even though x didn't have an exponent. So my highest degree is the 2. If I look at an example of a trinomial, same thing here. If I have x squared, my degree is 2. If I just have x, my degree is 1. And any constant, meaning just a number with no variable, my degree is always 0. So the highest degree out of those is 2 again. Let's look at a polynomial. So here I have a to the fourth b, even though there's not an exponent, still to the first. So that degree of that term is 5. The degree of the second term is going to be 3, then 2, and again my constant is going to be 0. So the highest degree in those terms was 5. So that's to the degree of the polynomial. So next, it says to simplify polynomials with addition, subtraction, and multiplication. We're going to clear grouping symbols using properties of algebra. So we're going to distribute a lot using these examples. It says we're going to combine like terms using the property of algebra, so commutative and associate. Meaning we're going to distribute combine like terms. So let's look at the first two sample problems. Sample problem number 1 has me using addition. So here I have negative 4x squared minus 3xy plus 5y squared plus 2 times 3x squared minus 3xy minus 5y squared. So before I can actually combine like terms, I need to distribute this 2 to my second polynomial or trinomial. So I didn't touch anything with the first equation, so let's go ahead and rewrite it. I have negative 4x squared minus 3xy plus y squared. Then I'm going to have plus, and let's distribute. 2 times 3 gives me 6x squared minus 2 times 3 is going to give me 6xy, and then minus the 2 times the 5, which is minus 10y squared. Now notice the only thing that changed here when I distribute was my coefficients. Nothing happened to my exponents. So now that I have distributed, I'm going to combine my like terms. Now you must be careful with the like terms. They have to match exactly. So here we're going to go in alphabetical order. We're going to start with my x's. So I have a negative 4x squared and a positive 6x squared. So together that's going to give me 2x squared. The next thing I have is a negative 3xy and I have a negative 6xy. So when I put those together, I have minus 9xy. In my last term, I have a positive y squared and a negative 10y squared. So I have a minus 5y squared. So once I distribute and combine like terms, here is my answer to adding the polynomials together. So let's look at example 2. This is going to be a little bit different because it's subtraction. Now with problem number 2, again, my first term, nothing's going to change. So I'm just going to rewrite my first term. Now with my second term, I don't see a number to distribute. However, it is a minus sign. So what number goes there even though it wasn't written? That's right, it's a negative 1. So you must distribute that negative sign to all three terms in the trinomial. So what's going to happen is all my signs are going to change. So when I have a negative times a negative x squared, it's going to become a positive x squared. It's going to become minus 5xy and plus 2y squared. So be careful whenever you have a subtraction sign. Make sure you distribute the negative. We're going to do exactly what we did on the last example and combine my like terms. So I have a 3x squared and a 1x squared, so I end up with 4x squared. I have a plus 6xy and a minus 5xy, so I'm going to have just xy, or you can write 1xy. I have a minus 7y squared and a plus 2y squared, so I end up with a minus 5y squared. So again, once we've distributed and combined like terms, that is my answer. So let's flip the page and look at a few more sample problems. Now here, it says I want to perform the indicated polynomial operation, simplify answers, and classify each answer by its degree and the number of terms. So here, I'm going to be multiplying. So when I multiply, what was my rule with exponents? That's right, I should add my exponents, and I'm going to multiply my coefficients. So what I'm doing is essentially distributing. So 3 times 5 gives me 15. I have x to what power? X to the first, and I have x squared, so I really have x to the third and y to the third. And then it's subtracting, again, distributing the 3, so I really have 18, because 3 times 6 is 18. I have x squared and y to the fifth. Again, all I did was add my exponents. Okay, now, these two terms are not alike. They cannot combine. So I'm done. That's my actual answer. Now what it asked me to do is classify each answer by its degree. So if you go back to your notes, we talked about the degree of each term and the degree of the polynomial. So here my degree in the first monomial is 6, and my degree in the second monomial is 7, and I got that by adding my exponents. So since 7 is bigger than 6, I have a 7th degree. And what type of equation is this, my answer? Is it going to be a monomial, binomial, trinomial, or polynomial? That's right, it's going to be a binomial because there are two terms. So what I want you to do is work 4, 5, and 6 exactly like problem number 3. I'm going to work problem number 7, and then I want you to finish problem 8. So let's look at 7. Okay, so let's look at some word problems. Number 7 says a rectangle has a width represented by 4x plus 5, and the length is represented by 3x plus 2. What expression can be used to represent the area of a rectangle? So first, let's draw a rectangle. It tells me that my width is 4x plus 5, and the length is 3x plus 2. So since I know I'm trying to find the area of a rectangle is length times width. So I'm going to take my 4x plus 5, and I'm going to multiply it by 3x plus 2. Now, most of you have been taught how to actually multiply this out. You've heard the term FOIL. FOIL meaning my first, my outer, my inner, and my last. Essentially, all we're doing is distributing. You're taking this first term and you're multiplying it by both numbers there, and you're going to take the second term and multiply it by both terms over there. So when I FOIL, I'm going to multiply. My first is my 4x times my 3x. So I end up with 12x squared. Okay, my outer are the two outermost numbers. So here I have my 4x and my 2. So I'm going to multiply 4x times 2. So I get 8x. My inner is going to be the two inner terms. So I have 5 and 3x. So that's going to give me 15x. And then my last are going to be the two last terms. I have my 5 and my 2, which gives me 10. From here, I'm going to combine like terms. So I end up with 12x squared plus 23x plus 10. And that's going to be my answer for the area. So again, that was 12x squared plus 23x plus 10. And that's going to be my area of the rectangle. So what I want you to do is use an area of the triangle, answer question number 8. Area of a triangle, remember, is 1/2 my base times my height. Okay, so I want you to finish problems 4, 5, and 6, and 8 for homework. We will work the rest in class tomorrow.